So we said that we have noticed that our ratios are equal, right? To some point, they are equal. Again, because we have to round, so the answer are going to be a little bit different, but they're pretty much the same. Now let's look at what will happen if I do sine A over A. Okay, so in this case, I have 0.660 over 26.4. So what do you guys get when you do that? What's after the 0?
1.
Okay. Yes, there's 5 decimal places here. It's okay. Do you want it to 4? Let's keep it to 4. I'm not going to go into the lesson of significant digits and the difference between significant digits and decimal place. This is a totally different lesson. But there is a difference between what we call significant digits and what we call decimal place. In this case, it's to 4 decimal place, but it's not to 4 significant digits. Okay? But let's not go into that. Sine B over B, so I have 0.9062 over 31.2. What is that? 6.3. Oh, yeah. I don't know why I'm writing 2 here. So what do you get when you do that?
0.0290, and next one is 4.
And this is going to be exactly the same thing, yeah? It's like magic. They turned out to be the same answer. Right? How come? And this is where the sine law comes in. Is because they figured that if every time they do this, no matter what the triangle is, if every time they do the side over the sine of the angle, the side over the sine of the angle, the side over the sine of the angle, they're coming out with the same answer. Right? So basically that tells you that if I know 3 things, so if I know a side and an angle, because it has to be the opposite angle, and if I know this side, let's say, I can use these ratios to find this angle. So it's enough if I know 3 things to find the 4th, and then that I can use another law to find the 5th and the 6th. Right? So all what you need right now is 3 things to be able to find the rest. Right? So they figured even no matter what the triangle is, if they use the side over the sine, the side over the sine, the side over the sine, they're going to equal to each other. Or the opposite way, the sine over the side, sine over the side, sine over the side, they're going to equal to each other. So here is where the sine law came from. Right? If I go to this, now we just discovered the sine law. Okay? Sine law says if I have A over sine A, it's going to equal to B over sine B. It's going to equal to C over sine C. Same as if I have the other way around. If I have sine A over A, it's going to equal to sine B over B. It's going to equal to sine C over C. Now, why do we have 2 formulas? Just to make our calculation easier. Okay? We get to choose which formula to use. If we are solving for an angle, then you want to use this formula because it's easier to solve. Okay? The way it's written, it's easier to solve. If you are solving for a side, then you want to pick this formula. Okay? Now, here's the thing. When you are solving using sine law, you only need 2 ratios. So you see how you have 3 of them equal to each other? You only have to pick 2 ratios. It depends on what's given to you. Is A and B given to you? Then you use the first 2. Is A and C given to you? Then you use sine A and sine C. Is B and C given to you? Then you use the B and C. It depends on what they give you, what information is given to you, then you decide which 2 ratios to use. So, here's what you need to have in order to be able to use the sine law. Other than it has to be an oblique triangle, you need to have two angles and any side. So you're going to solve for a side when you are given two angles and any side. Okay? So let's say if they give you this angle and they give you this angle, right? And any of the three sides, you can use sine law. Okay? Let's say if they give you this side, for example, right? You can't use sine law right away before you can find this angle first. So you're going to have to solve for the third angle, right? Because that's the one opposite to your side. And that's easy to solve for the third one, yes? What do I do?
You add these two and 8,
180. Because I know these two, and I know all three of them, they're going to add up to 180, right? So if I do 180 minus angle A, and then minus angle B, or you can add them and subtract, doesn't matter. Then you're going to find the third angle, okay? So now you have an angle on its opposite side. You have the angle. You can solve for either of the sides, okay? Now, the other option is if you have two sides. Now, in this case, you must have an opposite angle, okay? It's important that you have the opposite angle. So, for example, if I'm given this side and I'm given this side, I must have either angle A or angle C. Is C opposite to a given side? No. So I must have angle A or angle B because I need to have an opposite angle. Otherwise, I can't use this law. Okay? So because I know these two sides, I must have either angle B or angle A. Then I can use sine law. Does that make sense?
Yeah.
When we learned cosine law, right, and the rules for cosine law, then you will be able to kind of say, okay, no, it's not cosine law, then I have to use sine law. Okay? Cosine law, it's easier to determine if it is cosine law or not. Sine law, it's a little bit tricky. So remember with sine law, you must have an angle on its opposite side. Okay? You must have this combo, an angle and its opposite side. Otherwise, you can't use sine law. Okay? So, here's a question. So, it's you are given a triangle. You are given two angles and a side. Right? Remember, this is one of the laws. So, two angles and any side. Right? I can use sine law. And they're asking me to solve for side C. Okay? So I know angle B and side B. I know angle C, and I'm looking for side C. So in this case, I'm going to use sine law because it's an oblique triangle. Now, what ratios am I going to use?
You're gonna use A over sine of A.
But why am I going to use A? What? Okay, so I'm going to use this formula you're saying, right?
No, the one on top.
I'm going to find the side. So which formula do I use? Okay, that's what I'm saying. So we're going to use this one.
Yeah.
Okay. Now, which two ratios I'm going to use? B and C. And why B and C? Because we have B and we have C, right? So I have to use the B over sine B equal to C over sine C because these are the information that are given to me. Does that make sense? Okay, so B over sine B equal to C over sine C. What's side B equal to? 32 over sine 60 equals to, do I know what side C is? So it's C over sine 40. Can you guys stop writing for a second? I'll give you time to write. I want you to look at me. So you see that me writing this, number one, whatever I'm looking for is on the top. Yes, I'm looking for C and it's in the numerator. Good, it's easier to solve. If it's in the numerator, it's easier to solve. Number two, I know 3 things and I'm missing only 1. Does that make sense? That's right. Because if you're missing more than 1, then you won't be able to solve it. Okay? So, here's the thing. I want to know what C is. How can I isolate for C?
You have to take sine 40 on the other side.
And what does it become?
Multiply.
Multiply. Another way that I like to visualize it is by half cross multiply. Usually we do cross multiply, but in this case we're only going to half cross multiply. So we're only going to bring this sine 40 up here, so it's multiplication, because the opposite of division is multiplication. So that's going to be 32 sine 40, that's times sine 40 obviously, over sine 60. Yes? Which is equal to sine C. Does that make sense to you guys? Does it make sense why it's coming over as a multiplication? You can put a bracket if you want, or you don't have to. You can put 32 times sine 40. It doesn't matter. Does that make sense? Now here's my question. When you do this on the calculator, what are you going to report your answer to? How many decimal places? What am I looking for? I'm looking for a side. Side is reported to, what did we learn yesterday? 1. Sides to 1 decimal place. Angles to the nearest degree. Ratios to 4 decimal places. So, what do you get when you do this? You have to try it. So let's try it. 32 times sine 40 and then divided by sine 60. Guys, grab a calculator from the drawer, put it back when you're done. I want you to use real calculators and not phone calculators. They're backwards. They're going to give you lots of problems. I like that answer more. No, that's not right. Press the equal one more time.